Yeah. And first I want to thank the organizers for this, to invite me for this talk. And it has been an awesome conference so far, so I'm really excited. Okay, so hi and welcome to this talk about a new software architecture called Polylith. Let's start. So when I was a kid, I loved playing with Lego, and it was so simple and easy, and it was just a bucket of bricks that I could combine in almost any way to build almost anything. So how many of you have played with Lego? Almost everyone, yes. That was what I was thinking. So then you know it's really simple and fun. And then some years later, I started to program, and one of my first languages was assembly. And yet again, it was just a bucket of bricks that I could combine in almost any way to solve almost any problem. It wasn't easy, but it was super fun. And yeah, so I kind of loved it, and you can try it one day also, maybe. And then many years later, I found another really cool language called Clojure. And yet again, it was a bucket of bricks. This time it was functions and macros that I could combine in almost any way. And it was simple and fun and powerful. And I could, by just combining those functions, I could solve almost any problem I had. So that was really cool. But what about if we can't we use those principles at the architectural level? So how would that look like? Then we could have a bucket of code bricks that we could just combine, like Lego bricks, into services. So wouldn't that be really cool? I think that would be really cool. And actually, this is exactly what Polylith is about. So what is Polylith? So Polylith is a software architecture that applies functional ideas at the architecture level. And it's made by developers for developers. So I love programming, so I want other developers to love it too. So that's one why I created Polylith. And it's open source and free, and it has a lot of documentation. So, and why Polylith? So, I think one of the biggest problems in this industry is all the complexity that we create all the time. I think the Clojure community knows this, so we are good at fighting complexity. But it's still really hard at the architectural level. And Polylith is here to help you with that. So one really nice feature with Polylith is that it removes all code application. It's really, the default is kind of that it doesn't create any code application. And it gives you a really awesome development experience. And so it allows you to work, to create a really simple development environment where you can work mostly in a single repo. And if you add these things together, it's also really fun. It's like playing with Lego. So I mentioned this bucket of code bricks. And in Polylith, it's actually a bucket of components. We call them components, those bricks. So to explain them in a context, let's explain what a workspace is in the Polylith world. So a workspace is where we put our components, where this bucket of bricks lives. So a workspace is just an ordinary directory, no magic, and it's a single repo. Like if you use Git, it's a single Git repo. And we have a couple of directories in here, components and services. And the components directory is where we put all our components. That's our bucket of bricks. So if we expand this components directory, we can see that we have a number of directories in there, one directory per component, with the name of each component. So if we expand one of the components and look in that, we can see here, this is our component here. So we have a build file, project CLJ here in this example. And this file guarantees that we can compile the component in isolation. That's the purpose of this build file. And then we have some documentation here, a README file, and a source folder. And this is a simple example. So under our source folder, we have our top namespace. And here it's just the name of the component to simplify this example. And we have a number of namespaces in that, under that folder also. So, and the important namespace here is the interface namespace. So the interface namespace is where we put all our functions that this component exposes to other components. So that's the only thing a component exposes. It's what you put in the interface namespace. So what that interface, those functions in that namespace, what they do is that they delegate to other namespaces within that component. And you're free to structure your code the way you want inside your component. So if you open the services folder, we can see what our services. And here in this example, we have two services. So if we expand one of them, we can see that it contains a build file. And this is the file that builds our artifact that we want to deploy, our deployable artifact. So it could be a jar file, a war file, or something. It's up to you. So this is no magic here. And it has a source folder also. And here you can see it looks like we have a number of directories here. And that is almost true. But what it is actually, they are symbolic links, those directories. So here, the user namespace, top namespace here, you can say, is just a symbolic link to the user directory in the user component source directory. So that's how we share code in Polylith. It's just symbolic links. And that means you create your components once, and then you can use them everywhere in all your services. And what happens here is that what those symbolic links does is that it assembles all your code into one place with symbolic links. So the code behaves like a monolith, but it's not a monolith. It's just like Lego bricks that you put together. And this is really nice to work with because you can do refactor your code and stuff. And yeah, I will talk more about that later. Okay, so we have our bucket of bricks. So how does those symbolic links look like in this metaphor, Lego metaphor? So, for example, the user component here is used by the first service here. So that's just a symbolic link to the component. And the other service is using the same component too. And that's also just a symbolic link. So the component is defined and written once, and then it can be used from many places. It's very easy, simple. And if you want to add more functionality to our system, what you do in Polylith is that you just add a new component. And then maybe you want to use it in our first service here. Then we add a symbolic link to that component. Then we are done. So it's very, very convenient way of working. So that's the way you grow software in Polylith. You add components. That's a natural way of working. Okay. And a nice thing with components is that you can replace components with other components, and it works like this. So here, for example, we have a service that uses the mail component. And what about if we want to switch that component with another implementation? We can do that. So then we just add another component. And the cool thing with Polylith is that this interface namespace that I talked about, we can implement another component, like mailer here, that implements the same set of functions in that interface. And because of that, we can just swap implementation here, and without affecting the service at all. The service just communicate with that interface anyway. And now we have swapped the component, and everything just works. So let's talk a little bit more about components. So they are simple. So components are just code. They are not objects, so you don't instantiate them, or you don't need to configure them. So they are really simple. They have a simple name. Hopefully, you give them good names. And that means they are really easy to reason about, because they both have a good name. They are small. You can make them really, really small. Like in our project I work in, they are in average 400 lines of code. Some are just 100 lines of code. And I have a lot of components. So, and the interface makes it's really obvious what you can do with a component. You just go to the interface namespace and read what components you have there. So, yeah. And they are replaceable, as I mentioned. And it's like Lego. You just swap out a component. It's really cool. And reusable. And because you create the components once, and then you use them everywhere. It's so simple. And it's just like Lego. The feeling working with Polylith is like playing with Lego. And it's really nice to have those symbolic links that put all your code into one place. It's like when you're working with when you have a workbench, you put all your material and all your tools into one place, and then you work with them. So the feedback loop is super fast. You don't have more services than you need. You normally, the components is your new abstraction, you could say. So, okay, but is this so good? I mean, don't we just introduce a lot of complexity here and symbolic links and stuff? I mean, it sounds quite complex, isn't it? And we have microservices already that solve all our problems, don't they? And does it really work? Okay, so let's try to answer those questions. So, about complexity, when it comes to complexity, it feels like this component is the kind of the missing piece. At least that's my feeling after I've been working with this for a while. That actually allows you to simplify your systems, and it allows you to be able to reason about your systems much easier. And when it comes to microservices, I don't think you will talk about microservices so much when you work with Polylith. You will just talk about services, because components are your new kind of main thing that you will use to build your how to say, isolated building blocks. So your first choice will be creating components. And then you can have as many services as you want, or you need. So you don't start by creating hundreds of services. You start by creating one service, and to keep it simple. And then you add services when you need them. Then you can call them micro or whatever. It's up to you. And does it work? Yeah, it works really well. We have actually used this for 2 years already in production. In several various companies has used it already. And it works super well. It's really nice to work with. I haven't worked with something better, actually. So, and another thing I want to mention is that Polylith decouples the development environment from the production environment. And it works a little bit like this. So Polylith is very, very focused on giving you, as a developer, a really nice development experience. And so what you do when you create a new service or a new system is that you create a number of components, and you can work with them from one place in a single REPL. So that's how you start working with your code base. You create components, and you work with them from one place, as if they... So you work with your code base as it was one code base in one sense, but it isn't. They are like Lego bricks, but you put them together into one place. That allows you to work in a single REPL. It allows you to refactor your code as you are used to when you are working with a monolith. And you can debug your code across components. And it's much simpler than having a lot of services. If you don't need services, then it's actually much simpler to start simple, or better to start simple. So, but after a while, what happened to us, at least, is that some of those, so what happens to us was that it worked really well. In the beginning, you want maybe one service, but after a while, we recognized that, okay, let's say this invoicing it would be great to extract this invoicing and run it on its own service. So how do we do that? Okay, I will talk about that later. So, first I want to say, in the beginning, the development environment and production are like copies. But then when you introduce when you want to break out some functionality, in this example, we just introduce a new invoice remote component in this case that has the same interface as the original invoice. But the thing this component does is that it delegates the call to the invoice service. So what has happened here is that how we run the code in production is more like implementation detail, you could say. So we want to keep the development environment as simple as possible, as long as possible. And we can also have several development environments if we want to. But normally, it's actually a good idea to keep the development environment really simple, so you can work in a single REPL. But the production environment, you're free to just extract your functionality into new services. And because the components are decoupled, it's super easy to create a new service. So it doesn't take much time to do that. I want to mention a tool that we have built. It's a lining and plugin. And it helps you with different things like creating components and visualizing a Polylith project. But I think the most important thing it helps you with is that it allows you to build and test your code, your services, and your code base incrementally. So, for example, if you have 100 components and you change one component, then this tool, it's a Lightning plugin, as I said, will detect that only one component of those 100 components has changed. So it will only compile 1% of the code base. And then it will detect what other components are using this changed component. And let's say 2 other components use this changed component. Then it will only run a test for those 3 components. So in this case, it will run 3% of your tests, all your tests. And this encourages you to run your tests often, because we use this plugin locally when we work with a Polylith code base. And we also, when it's time to push your code, we also use the plugin on the CI server. So then we know, and this builds up a really good confidence that the code works. If it works locally, it will almost always work on the CI server. So you just test your code locally, incrementally, and you push your code, and then you're done. So, yeah. So I want to mention that we have this high-level documentation. We have spent a lot of time on that. And we have this plugin that I just mentioned. We have spent a lot of time on that documentation too. And we also have a full-blown application. So if you want to look at a working system, you can go there. And if you have any questions, you can just go and ask us at this forum. And who are us? It's me. I'm the inventor of this idea, and I also have 2 awesome friends that has been working a lot on this also, Ferk and James. James is here, by the way. And that has been really awesome to work with them. And to sum it up, Polylith, it's just like Lego. It's just like code you put together to create your services. And it helps you fight complexity because you have something, this is kind of this missing building block that you could use as Lego. It's really cool. And it doesn't produce code applications, because the default is to create a component, and when you have created the component, you just use it, and then you don't have code application. And it gives a really awesome development experience, and because you run the code in one place, your IDE can detect dead code, you can refactor code between components, and so it feels like you get all the good thing with a monolith. So it's, if you ask me, a monolith is kind of have many good things that comes with it. So, but Polylith kind of takes all the good things with monoliths, but discard all the bad things with it. And also, when I started to work with Clojure, after programming with Java for 20 years, I got that really nice feeling of, wow, this is something simple and powerful and fun. And it's also just like Lego, building with Clojure. And during those past 2 years with Polylith, I I have the same feeling that this is something simple, powerful, and fun, and I hope you can try it out and see if it's as fun for you. Thank you.
Thank you very much.
Thank you.
It was awesome. I think it's a very nice ambition to build a software tool that is as much fun as playing with Lego. So that sounds about right to me. I think we have time for a few questions. If you are happy to take some questions.
Yeah, sure.
And there we have a first contender.
Hi, thank you for a wonderful solution to the monolith and microservice dichotomy, I would say. Are components always stateless? That would be my first question.
They are just code. So you can think of it as if you have a monolith, just chop it up. And if it compiles, then you have your component. If it compiles in isolation, you can think of it like that. So everything you can do with a monolith, you can do with a polylith. So they are, yes, they are stateless, you could say. But of course, you can have you can initialize, you can have atoms or whatever.
All right, okay.
But no, they are not instantiated. They are not objects. It's just pure code.
But they can contain state if they wanted to, I understand. Okay.
Yeah, so it's just, actually, yeah, you can think of them as, you can think of a component as a really tiny monolith, really super tiny monolith.
Great, and does it work with ClojureScript, this framework?
We haven't tried it. I would say it's mostly a backend solution. That's how I see it. But I think you could share those interfaces maybe between front and the backend. I could see that work.
Thank you very much for the question.
So you have components that are connected by interfaces, and these interfaces are defined somehow. What type of semantics do you support for these interfaces? Just like call and return, or do you support also in queuing, or like send and forget?
Yeah, you can. You are totally free to put whatever you want in those interfaces, in that interface namespace. And this is really normally you just have one namespace called interface, but you can have more. But let's keep it there. And what you normally ends up with is that you have just pure functions there. You could have macros. You could even have def statements. So everything you put there is what you expose to other components. Yes?
Thank you.
Oh.
I think we have one more question here.
Yeah, I wondered why you made symbolic links to source directories.
Yeah.
Then why do you need the project CLJ
the
level higher?
The thing is that the components, each component are compiled separately against all other interfaces of all other components. And they are actually compiled against, I didn't mention it because I didn't have time, but we have a version of each component interface that are empty, with an empty body. It's just the signatures of each. So we have actually one more directory called interfaces, where we put all those empty interfaces of each component. And we compile that to a jar. And then we compile every single component are compiled against that set of empty interfaces, kind of the definitions of all components.
One last question. I think I saw one there. Is there anyone else for who I don't have to walk as much?
Hi. My question is basically, can you reuse code also between components? Either you have like something like subcomponents, like for example utility functions or something like that you want to use in multiple components?
Yeah. We have kind of infrastructural components called database, mail, or logger, or whatever. And we also have like business logic, like invoice, purchase, user, whatever. So you're totally free to have whatever components you want. Yeah?
If you can nest components.
Yeah, think of it like this. Think of it as like the bucket of Lego bricks. So all components can access any other component, but if A depends on B and B depends on A, then you get circular dependencies problems. So that's not allowed. But this kind of solves by itself, because what you do is that you have maybe a database component, and that will not call the user component, because its responsibility is just to take care of the database. So there hasn't been a problem. It kind of solves itself. The hierarchy you get kind of the components, you can have business logic components, and then you maybe have those more like helper components.
If things are not clear, then I think you will find each other in the hallway and sort it out. But I think everyone is really excited for lunch. So we're going to do 3 more questions. No, just kidding, of course. Yeah, thank you very much for attending the session, and enjoy lunch, and see you here sometime later.